All right, hi, I'm Thomas Lodato, as Kirk already said. I'm a research scientist at Georgia Tech, so I don't get the distinction of being a professor, but I do appreciate the nod. And Jennifer Clark, who's the director of the Center for Urban Innovation, is in the back, and this is our joint research. So today I'm going to talk about a project that's been renamed Wrangling Legacy Data, Preparing for Socio-Technical Change in the Smart City. But before beginning, I want to acknowledge some contributions to this. Chris Thayer, who's a graduate student, did a great deal of work on this project, and it wouldn't be possible without her, as well as Emma French, research scientist at Georgia Tech as well, that's helped with the open data component of this. So I'm going to do some coordinated choreography. So I'm going to start with a provocation here. If data are so important to the smart city, why are data so rare? So I imagine some of you might be puzzled by this because you think that we're overrun by data, and that's very true. And some of you may be in agreement with this in the sense that you've dealt with the sort of difficulty of creating data. But I want to get a little more specific than simply saying that data are scarce. So by data, we mean two things in this project. First, we mean open government data, or OGD. Open government data are non-privacy restricted and non-confidential data produced with public money with no restrictions of use or distribution. So although OGD are about governments and produced by governments, they're also produced by businesses and citizens. And they sort of constitute an important part of understanding what a city does and how a city functions. I'm sure you're all very aware of that. So secondly, what we mean by data here are machine processable open government data. These are data that are structured in a way to be best suited for automated processing. And what that means is that they're a step beyond being machine readable. What that means is that they're not simply able to be parsed by computers, but actually they can be sort of put into algorithms. There can be prediction done with them in an ordered way. So as such, open government data that's machine processable is deeply important to the smart city in that it actually gives us insights into the public services and operations of a city. So now I want to give a little bit of detail to what I mean by scarcity here. So if we look at this ongoing effort from the Sunlight Foundation, Code for America, and Open Knowledge International, called the US Open Data Census, which was launched in 2014, we actually get some numbers behind the scarcity of open government data as machine processable. So what this does is they track open government data in the US through US cities. So volunteer organizations come together using 9 criteria to evaluate data sets. Those data sets are then scored, and then a city is given an overall ranking. Currently, there's 101 cities across the United States that are actually represented by the US Open Data Census. So across these 101 cities, there's 1,111 data sets, of which 56% are actually machine readable. So as a basic criterion to whether these can be machine processable, only half actually can be. Even more, only 50% are actually both machine readable and downloadable in bulk, meaning you actually can do some sort of group processing on them. And the Open Data Census lists that only 37% of these are actually even open. So what this says is that while this might be dated information, right, some of these things are sort of dating back to 2014, there's sort of a non-trivial concern here. And if we want to put this into even more detail, the 2012 US Census Bureau listed that there's 19,500 municipal governments in the United States. So the 101 cities in this actually only constitute 0.5% of cities in the United States, right? So, and these cities that are actually represented are the ones that are on the top of the list are those that have a lot of resources, right? San Francisco, Las Vegas, New York, Chicago, Austin, Texas. So Atlanta is ranked 24th based on 2014 counts, as well as an update in 2016. So with all the efforts, I imagine this might be a little different, but it's important to just point out. So looking closer at the Atlanta census, we see that there's 18 different data sets here, 6 of which are actually machine readable and downloadable in bulk. So 2/3 of the data at this time, and potentially even now, are not actually able to be put into machines for a variety of reasons. And given recent efforts, this might be different, as I've already noted, but some data sets, such as budget data for the city of Atlanta, ultimately actually hasn't been updated since 2014. So what we should take away from this is that machine processable OGD is non-trivial, right? This would otherwise be done. So we look at a different portal, data.gov, which is a federal level portal. We get sort of a different view. So there's 195,422 data sets, 16,400 about that are about local governments, 6,600 that are actually produced by cities, and 25% of those are from New York, right? And 0 are listed from Atlanta. So this isn't to say that there are no open data sets, but it's not being used by all cities, and particularly this city. But it drives home an important hypothesis that we have. So data scarcity is not a technical problem. We shouldn't think of it as a technical problem because data scarcity is something that we know about. We know what formats are capable of being used. We know how to structure data in optimal ways, and what a data portal can be, and even that they exist and they're freely available already out there. Instead, what we end up seeing is that data processes and procedures aren't done consistently or implemented at all, leading to inconsistency and therefore scarcity, that is, actually having access to these data. So as such, we need to think of open data and open government data that's machine processable as not an intractable technical problem, but as a socio-technical one that includes personnel and skills, includes administrative procedures, as well as dedicated resources and so forth. So if we look at the landscape of data production, circulation, and use, we can refine this even more. Technological change is a huge barrier to machine processable data in that technologies change. Current technologies become legacy systems in that they become old or outdated or obsolete, even if they still work. This leads to issues like connectivity, right? Just trying to connect to projectors, for instance, sometimes can be a difficulty because you have old ports or new MacBooks or whatever it might be. As such, the data produced in these legacy systems, what we call legacy data, also adhere to these sort of old standards and therefore have issues with getting sort of integrated into a smart city system that needs to do machine processing on them. So the diagram here illustrates 2 points. One is that legacy systems are not just like static state that we can overcome, but inevitability with any sort of system, particularly the smart city as a system. And secondly, that they also extend beyond the purview of computational technologies, right? Paper is a great record-keeping technology, and it's something we need to consider when we talk about computational technologies as well, because paper records still exist. Okay. So given this, I want to set out a little bit more about what we ended up doing in this, and the empirical work that we did, which is we wanted to understand the process of making legacy data into machine processable data in order to unpack the barriers and challenges that are of the impending sort of data production, circulation, and use. So in other words, we wanted to understand what it actually means to do this work, not just how to do it. Okay. So we went through a pretty sort of a diagram, a very simple process here, but we're going to show that it's actually much more complicated. We took adopted budgets from the city of Atlanta and then turned them into Google Sheets that can be exported as CSVs, tab separated, and Excel files, right? And while this might seem like a pretty straightforward process, there's a lot of sort of complexity here that we're going to unpack. These files date back to 1996 up to 2017 and constitute a lot of different types of work, which we'll go through now. So there are 5 findings that come out of this research, and through these findings we'll go into what we actually ended up doing. The process we went through is called constructive design research, which is a process of making in order to understand. And so we're going to go through each of these in turn. All right, finding 1. Try to punctuate this by saying finding. All right. Finding 1. Domain knowledge matters to wrangling data. Wrangling data is the process of making data useful. So while this may seem obvious, it's important to note that where a lot of data approaches actually think of data as sort of agnostic, that you can approach data through insights, we need to think about what and how data are produced. So I'm sure you're all familiar with this diagram of how a city actually makes a budget, and particularly the city of Atlanta. But for the sake of level setting, I'll go over this real quick, right? So there's 3 basic documents that we're talking about in terms of data and the production of budget data within the city. The first is the proposed budget, which comes from the mayor through and takes into consideration a resolution from the Finance and Executive Committee. And those set the priorities for the year from the mayoral sort of the office, right? And this comes out in May. Then that goes over to city council for debate, and it's adopted before the fiscal year, so that by the end of June. And then a bunch of stuff happens, which is the squiggle here, right? So you have bridges collapsing and whatnot, right? I didn't know how to best represent it, so squiggles may be the best way to do that. You all do your work, right? And then at the end of the year, right, a comprehensive annual financial report is produced, the CAFR, which looks backward, right? So this is an auditing document. And then a resolution and so on and so forth, right? So this is the grind that exists. So what we need to point out here, and this is important when we talk about sort of domain knowledge, is that there are actually 3 different data sets, not data that becomes increasingly more faithful to what actually ends up happening, right? Proposed budgets are promises made by the mayor's office. Adopted budgets are those made by city council and the mayor combined about what they're going to do. And the CAFR actually looks backward. So the first 2 documents are actually budgeting documents in that they're estimations, where the CAFR is not an estimation, it's an auditing document. So where one looks forward, the other look back, and the questions you can ask of these data differ. And that's important as we go forward. All right, finding 2. Wrangling starts with data collection. So what this means is that we need to establish a data corpus, which is the extent of data that exists in the city. So say you want to start with this scenario. How well does the city of Atlanta actually budget? Right? Then what you actually need are a certain type of data. So you actually need to compare documents. Right? From no one document can you actually get this answer. You need to compare what was promised in a budget versus what actually ended up happening, right? And that comparison gives you a sense of how well the city did. So what we had to start doing is by establishing a data corpus to actually answer a question like this. So the data for budget expenses and revenues comes from 2 sources currently, the Department of Finance website and a bunch of different PDFs, so the adopted, proposed, and the CAFR documents. And then the Atlanta Budget Explorer, which is a visualization built in Tableau that there actually are machine processable data sets available through. Yet if we look at the ABE, the Atlanta Budget Explorer, we actually don't get the data we're looking for. What we end up getting is primarily CAFR data, and then when that's not available, we get budget data, adopted budgets. So comparison of how well a city did over years actually isn't possible with this data set. And so it actually begs sort of the opening up of other data sets. So as such, in this first part, what we ended up doing was, in order to get data in the right format, you need to get data. And we need to establish what that data are, what those data are, here being sort of adopted budget data. Since we have some available CAFR data already in a machine processable format, we decided that this is a sort of place to start. All right. So finding 3, extraction requires synthesis. So I imagine you all are thinking, you did just take data and put it into a spreadsheet, right? That's what this person's telling me about. So in a simple way, that's actually exactly what we did. We started with. So what you see here is a budget document, and then you see the same value in our spreadsheet, right? This is what is imaginable as what you would do in terms of extraction. But extracting a datum like that requires actually having some sort of organizational structure, some sort of schema that actually makes this data set legible. So automating it isn't necessarily possible, even if we have algorithms that can parse through PDFs. But ultimately, also, we see other instances where rote transcription actually isn't even possible. So in the 2003 budget, we found a $1 million error between 2 lines. Right, it's a typo, so nothing's going on here. But ultimately, it's important. So it's about the 2002 budget and the 2003 adopted budget. And so this doesn't matter to the data set where we collected fund summary data, but ultimately it did matter when we talk about the change values. So here we actually see the difference between a 21% increase versus a 10% decrease, right, depending on this typo. So if you're extracting data in a rote way, saying I'm going to take the value out of here, which data do you actually pull, and how do you note which one you're actually taking so that someone can verify whether you took the right one? So what we ended up doing is pulling the sort of smaller value, so it actually was an increase that we saw, but also annotating these cells with cell-level metadata so that someone can verify our work. Right? Say, for instance, we chose the wrong value because we confirmed it the wrong way. By producing cell-level metadata, we actually can say something about what ultimately, someone actually looked at this and say, oh, actually, it's the wrong one. We know where you got it from. So we showed where pages were coming from. So the originary documents actually provide a resource rather than just this data set being the only thing you look through. So even more, I realize we're looking at spreadsheets. Other data needs to get produced to distinguish between types of values. So a 0 value might be represented in a budget, right? There's no money in this fund. But in a spreadsheet like this, it may actually correspond also to funds you haven't gone through, right? So you see TBD, these are files we haven't actually gotten through yet, as well as no mention, meaning that there is no mention of this, but so we don't know if it's 0 or it's just simply left out of the document. Again, accounting for the potential for errors. All right, finding 4. Schematization and normalization are iterative. So I already mentioned this, right? We need to have some sort of structure around this, and I'll get into this in a little bit more detail. So across the 21 years that we're actually looking at budget documents, things changed. I mean, I guess that's pretty apparent. We had new mayors, and there was an Olympics, and all those kinds of things. And so what we did initially was do a sample of these data sets to try to establish some sort of overarching structure. And this sort of holds across all of them, where you have fund groups, and then funds, and then sub-funds. But also, these things change inside of that structure, and it's important to note these. So in 2007, the budget fiscal year changed, what it corresponded to. What you actually see here is an excerpt from a document that identifies this. So prior to this, the fiscal year actually corresponded to January to December, a calendar year. And after this, it corresponds to the July to June fiscal year that we currently have. So when you compare 1996 to 2016, you actually are comparing different types of calendar years. And it's important because it matters over in the long run what we're actually comparing and then the kinds of conclusions you're going to make. So here again, this is only possible through actually going through this iterative process of refining the sort of organizational structure and annotating that organizational structure. But also you see funds change. So this group insurance fund changed from one fund group to another fund group. And this change ultimately meant that we need to create more sort of organization for machine processing. You need to create unique identifiers, where previously the group insurance fund itself, the name, it wasn't uniquely identified. Now it actually exists in 2 different categories, and therefore we need to create unique IDs. Again, talking about the sort of ways in which these things break down as we add more data. All right, finding 5. So documentation describes data and data wrangling. We actually already talked about this a little bit, so I'll be real brief here. So as we look at metadata, we see descriptions of files, but also descriptions of processes. And I'm going to show this again. This is the description of where data came from. This is ultimately important as we think about implications for what the sort of ongoing process of data wrangling for legacy data is and who does it and how it gets done. All right, so from all of this, we have 4 implications for what we can think about when we think about smart cities and data. The first is that questions drive OGD. So rather than thinking of data as holding insights, we need to think of insights being supported by data. This maybe is a small shift, but an important shift because one constitutes research where the other one constitutes sort of a problem for empirical work. So this means that OGD needs to be prioritized based on pressing concerns rather than generic ones, right? We need to have data open. We need to figure out what actually is important to a constituency. Secondly, internal capacity and knowledge can't be outsourced entirely. What this means is that where we use contractual relationships like public-private partnerships or city-university partnerships, there needs to be internal capacity in departments to actually identify whether the relationship is actually the right type of relationship and the data that's produced is the right type of data given the circumstance. But also that there's some sort of institutional memory around this, right? Governments may be considered slow, but that's actually very good when you're making decisions on behalf of a public. Third, interoperability means preparing for change, but not just in the current moment, but in the future moment, right? So where we think of open data as being helpful in terms of making systems that currently exist communicate, we also need to think of this as going sort of on a larger time scale. And then finally, a smart city is well documented, meaning that we need to think about verifying our processes for data quality, but also as technologies change and shift, institutionalize them in administrative processes. All right, so that's all for me. Thank you. Well, questions at the end.
I'm going to pick up where Thomas left off and try to keep it really short so we have some time for questions and answers. Let's just go to the next slide. Okay, and I'll just keep going next. So these are the things that my program works on, and we're sort of at the intersection of buildings, the processes of delivering, architects, engineers, contractors, owner-operators, delivering buildings, and then what we do with that data. once you generate these buildings, you have all kinds of rich, now increasingly three-dimensional, called building information modeling data that we think we can start using as a basis for doing two things: connecting up and starting to look at how maybe the buildings that the City of Atlanta owns kind of fill in the overall smart city, and then if you go the other direction, how building sensors and things like that, the kind of computing that's all around us, that's in the building operating systems, things like that, how that can get connected as well. So we're also very much focused on this kind of question about the integration of all this information so that folks like you and the people of Atlanta can do valuable things with that. So next. So I think I talked about that. Yeah, we're looking at integrating the building view of the world, the city view of the world, and the device view of the world, connecting smart buildings and the environment, so building control systems. We'll talk about what we're doing at Georgia Tech, how we'd like to apply that to Atlanta as well, and then use that as a case to take it to the rest of the world. Next. Just on our side, these are just some apps about the kind of this Georgia Tech as a campus. It's almost, well, we think of it as almost a city of its own, but of course it's part of the bigger Atlanta environment. And the students on campus, the facilities people, they make there's a ton of this stuff around, right? There's little apps, there's databases of information. We're starting to map that stuff onto kind of this overall view, but we don't have a kind of a platform, as we like to call it, where all that stuff can kind of come together, and you can mix and match this stuff in useful ways. So next. So this is just this is kind of a technical view of what we're trying to do. At one level, again, you guys have a lot of these data services. Maybe they're spreadsheets, maybe they're servers, maybe they're actually on the web. We'd like to have different ways of kind of mixing and matching that stuff and making it work together. And then what's emerging is there are open standards, and Thomas, I think, mentioned this a little bit, but there are increasingly sort of city-level views of the world, kind of ways that city data talks to each other. And sort of a lot of stuff isn't in that format yet, but if we can sort of create sort of a common denominator, then we can feed it to these different viewing applications, and again, mix and match it and slice and dice it in interesting ways. So next. Let's see, just Kirk was kind enough to sort of help the process along, and I don't know if you guys are aware of this, but this is like 30 of 70 of the available data sets that the City of Atlanta manages. Anything from life safety to school zone flashers. That's a fave of mine. I guess every time one of the bus stops or something like that and the lights go on, it's got it actually, I mean, there's just tons of stuff that you guys have, right? And some of it would be useful in different cases if you can combine it to other things. So connecting maybe all of the traffic-related data or all the safety-related data, once we can connect that stuff, you might actually, maybe if there's an accident, then we can see that those accidents happen more frequently when the school bus flashers are going or something like that, right? Different sort of cross relationships that you wouldn't know about if you weren't able to pull that stuff all together. So next. And we've done a little bit with the City of Atlanta data already. There is, for example, a Marta API. I don't know if you know this, but there is a website that, as Thomas mentioned, a computer can go to and just literally kind of scrape. These are every bus in the City of Atlanta, where it is, what its number is. You can see the latitude and longitude. That's where this bus actually is right now when that picture was taken, right? On the left is some other data sets that have been started to being exposed in this kind of normalized fashion. Parcel information, 311 issues, where the street lights are, 5 or 10 of those 50 to 70 data sets. We're starting to actually expose those, or you guys are, and we're working with it. Next. This just says we processed the bus data in real time. Yes, there's that fabulous Excel spreadsheet doing its magic again. Next. And then we started looking at kind of what's available from a city level viewing capability. So one of my colleagues, John Taylor, who's going to speak next time, found out that for $300 you can get a pretty good 3D model of the City of Atlanta. Just available. We found there's actual City Marta buses online, little 3D buses that you can get out of what's called the 3D warehouse. Actually has the Marta logo on it. And so again, it's just like, how can you mix all this stuff up in a way that's interesting? So next. So this is kind of the first view of this platform, and you can make of it what you will, but we're just starting to take that city data set and then start mixing and matching different data on top of that. So can we flip over to the other thing? We'll just show you a real quick demo. Yep, there we go. So just here it is live. Sinisa maybe can just spin around a little bit and zoom in with the so this is a new research scientist who's going to work on this, and he's actually never flown this thing before. But you can see the individual parcels. We're going to Google Maps, which also has an API to figure out what the street address is, blah, blah, blah. On the left are a bunch of different sort of visualization filters. So this is just showing distance to the North Ave station, which is kind of the crux of where all the buses go. If you click on maybe the origin or the destination, yeah, you'll see a different view. This is where the people are coming from at this time. So I think you'll see people are getting on the bus more in North Station and they're leaving and going to other places. The destination, let's see, it's kind of the opposite where people are going, I guess. And then if you click on the stops and then zoom in at the upper left, stops, one of the buttons, yeah. And then zoom in with the mouse. We should all be doing this. This would be a good exercise. There you'll see some of the, there's the little bus stops. You'll see these little flags of the bus stops. Anyway, so this is just 3 data sets that we're pulling together and trying to do interesting things. And you might say, I actually wonder on a given day where people are coming from and where they're going, and is there a way for us to understand that better? Let's go back to the presentation. Next. Yeah, this just shows the, so again, just taking the database of all the Marta stops, and those are some images of the Marta buses. It's not actually crashing into that building. It's a little bit kind of a higher resolution, so don't worry about that. But yeah, starting to sort of look at the real-time view of these actual little buses that we got off the web and how we can position them. So next. All right, and then on the building level, this is just sort of 2 more quick points. We can mash up a bunch of this building level data too. So this is what's sometimes known as building information modeling, or BIM. It's the next generation after CAD, where people are starting to build buildings off of these 3D models instead of just plans and sections, right? And so once we have that data, it's available to be used elsewhere. And we think that sort of this bridge between buildings and cities, cities have a lot of buildings in them, and you can't go too far before you have to go into a building, right? So making that connectivity between the building view and the city view is a big piece of what we're trying to do. This is just showing a couple of the buildings on the Georgia Tech campus, again, sort of pulled into one of those big databases online. Keep going, next, some metadata. And then, the last piece is connecting the IoT or the smarts to those things. So same basic idea. There's all kinds of sensors around there. There's this concept, I think you've all heard of IoT, Internet of Things. All of these different devices like that thing, right? That's a little computer. It's not very smart, but it knows the temperature. If we can connect that into this, into this big pool of data, we can start maybe finding out what's the variability. Are there rooms that are like excessively heating when they should be cooling, blah, blah, blah. But again, like Thomas said, they all sort of talk in different ways, and we have to come up with kind of the unified ways of thinking about cities, buildings, and these devices in order to allow this kind of flexibility to happen. So next. I'm just going to go to the end. Next. Yeah, this just starts saying, here's the kind of the view of the smart city view of the world. There's sensors at the bottom. There's storage, all the stuff that Kirk, is a genius about, all that stuff. But then at the top, smart government, smart transportation, smart education. Same thing on the IoT level, so city management, environmental. This is the kind of the device view, the buildings in the middle. And we're just starting to kind of create those maps across those use cases so that we can figure out how stuff will flow nicely across and we can do useful things with it. So next. Okay, so this is the pitch. We want to work with you people. We have these tools. We have the kind of ways of mixing and matching stuff, but we don't know what's important. So if this was interesting to you, please talk to us, and let's figure out something that we can use these tools for that is valuable to you guys or your communities. We'll hopefully get connected to the data. We're working with Kurt and those people to just get access to it. If there are open standards that we can plug in, that will help. And then we want to develop those viewing, filtering things and provide maybe the viewers either to your internal staff or to others in the city. So that's all I've got to say. I hope that was interesting enough that we can talk about it in the future.
So as it relates to wrangling your data, are you saying that you're at the beginning stages, or have you done it already? And if so, it's a long question. Okay. Can you say you've had a light bulb experience in the sense that so you've wrangled your data and you go, wow, this is super for Atlanta, and can you pinpoint something that's unique to Atlanta compared to another city? It's pretty long, isn't it?
The answer to the first part is that the wrangling is a perpetual state of being, I think, is part of the way we would talk about it. So what we're reporting today is the findings from our first round of doing that work specifically on the budget data. Obviously, any one of the 30 lists of data could have a similar sort of intervention that happened. What we wanted to do was share first the findings that we from going through this experience the first time. So part of what we're trying to share with people is that this is, as Thomas said, a non-trivial exercise. And I think a lot of times what we see is people say, oh, we'll just make the data open, there's a machine, you can automate this process, and what we're finding is that is not the way this works. I mean, ultimately we would like to get to a place where citizens and community can engage that data, but making that available to them in a way that they can actually interpret it is going to be a project, an ongoing project, and to be fair, it needs to be actually considered as something that has to be programmed as part of the city budget. Do you want to answer?
I think that's covered.
They mentioned the different communication protocols or in a building environment. Because I know like Johnson Controls, Siemens, different type of companies, and none of that stuff talks to one another. How can you get an open platform or platform where it gets their commercial interest, where they're going to come together? Because I don't see those companies in that space opening up to other different companies for their commercial interest. So.
Okay, so it's kind of a two-part question. Let me maybe just tie into what we talked about yesterday. So the last question. Certainly, there are a bunch of useful open standards out there, and one way of making the data wrangling easier is if when you create your data pool and expose it to the community, you pick one or more of those, right? And so the building energy world is an excellent example. There actually are open standards. One is called BACnet. It's actually developed by an organization in Atlanta, or that's headquartered in Atlanta, ASHRAE. Actually, Johnson Controls does speak BACnet. It's just one. I think there's 2 or 3 others. And now I've forgotten So how do you motivate? I have a theory about this motivation because we work with Autodesk a lot around BIM and open standards, and the answer is they're not opposed to it. They're just busy, right? And they will respond to the customer's needs. And if they hear that loud and clear, they'll go along with it. There is this sort of sense like everybody's trying to hide their information, but the fact is they know this is happening, but they're also inundated with 6,000 different options on how to make it happen. But I think the short version is if what we're trying to do is answer the why, right? Why does it even matter to have it open? And if we do, then I think folks like you guys can work with your vendors and say, if you want to be selected by the city, you gotta do this. Sorry. And rest assured, if they're going to win a contract with the city of Atlanta, they're going to say yes, right? So I think it's easier than, it's not trivial, but it's easier. There's a way forward, right?
Yeah. I mean, just to go on that, and Jennifer will probably maybe echo this in more detail. This is where data sharing agreements are really important, and establishing those up front, right? So vendors need to be told what you need, and you need to know what you need to ask for. This is just part of the point of our project, which is saying that this is an internal capacity. It's not something you can simply just say, well, we'll set up something with Siemens to get data in here, and they'll do what they should do best and be in our best interest. They're ultimately going to do what's in their best interest because it's what makes it most efficient for their systems.
And if you ask for it up front, you'll get it for free. And if you ask for it after the fact, you know how it goes, right?
Just on the, I think this is a really crucial question, and one of the last points in terms of implications was the interoperability point, and that it just goes across all of these different stories, right? This question of interoperability because of the question of legacy systems, but also so that you can move from system to system, but also the multiple layers of systems that they're put in at any given time, as you're discussing. So I would just encourage people. The National Institute for Standards and Technology has been trying which is a federal level agency in the Department of Commerce, has been trying to work towards this goal. It is not a well-resourced project, but it is one of the things that they're trying to do is set a platform out so that when the implementation of smart cities goes forward from city to city and between cities, there's actually communication that can happen, not just in a given city, but between cities as we optimize this whole story.
As you've gone through your analysis and looking at different cities, have you found any city that you would say is down the road in terms of following along the path that you guys are working towards, that maybe a city of Atlanta can use as an example?
So, I mean, in that the Open Data Census, and as well as with data.gov. You see sort of cities you'd imagine, right? Resource-rich cities like New York, San Francisco, Austin, Texas, Chicago. It's not that those cities that we don't know what those cities are and what the standards are. It's the truth is that they cost a lot of money to do them that way, right? New York has Bloomberg backing a lot of this, and that's very important because it ultimately is a data analysis company that can actually push through how data should look. It's not free for everyone else, and so where you see technical assistance programs that provide in-kind resources to sort of first-tier cities, the ones that are getting in as the doors are opened, second-tier cities that need to sort of follow the lead have to foot the bill. So it's not really an issue of whether we know the models that are successful, it's actually figuring out ways to actually fund them, staff them, work through these processes, and build up internal capacity, right? There was a recent workshop we did where someone from the city of Donaldsonville, the mayor actually, came and talked. And they installed this amazing broadband, or tried to install this broadband for 200,000 people for a city that only has just under 3,000. Because they wanted to see what would happen. And it's not that they didn't know how to do it, it just was a matter of figuring out the process, right? So I think that's the important part here is that we have models, but it's a matter of actually implementing them.
And just to add to that, one of the interesting things that's sort of happening under the radar is small, and Thomas really alludes to this, is small cities who have essentially smaller data sets, right, who are making this open, and they actually have the capacity within their city to do a lot of this data wrangling just within sort of as they do regular operations, and this is an interesting thing for them to do. So like Juneau, Alaska has made a lot of open data available in such a way that you can actually look at it. It's a very large territory. They get kind of an unusual amount of federal money in Alaska anyway, so their resources are a little bit different. It's a different kind of story in terms of resourcing it. But they're also a place to look for models. And it's interesting that we're seeing it both from the top and from some of the smaller cities as well that just have a different scale that they interact with.
Maybe I can just follow up on that because I'm recently relocated from Boston and LA. I'm really enjoying working in the city of Atlanta around this stuff because it's actually really, it's really accessible, right? And I think, getting connected to a guy like Kirk and the stuff that's actually happening in this building, in this very basement, there's a lot that's happening here, and I think we have to, and I think to your question, sir, the answer is nobody's got it figured out, and I think we're in the running, and I think we should beat those people, right? I think Atlanta is the place that we should make this happen, and this relationship between Georgia Tech and the city, between folks like Kirk and people like us, and as you know, the mayor and the president, I think there's a good critical mass of people working on this, and I don't think we should. I think we should beat them.
We shouldn't cede the territory.
Yeah. Okay.
All right, it looks like that's it then. Last call on questions. Okay. Well, thank you very much. I appreciate your coming here and presenting to us. Again, I think a round of applause. And